Hello, this video is introduction of basic operation guide of Keysight E4727B Advanced Low Frequency Noise Analyzer. Keysight E4727B is a measurement system of low frequency noise like 1/f flicker and RTN of semiconductor devices. This is the outline of this video, and you can understand all over the Keysight E4727B from hardware to software. At first, the video objective is introduced and explain hardware configuration and connections. Next, the actual duty connection is explained. Lastly, software operation and data viewing is demonstrated. The objective of this video is to expose engineers on how to use Keysight E4727B, especially hardware configuration, the connection between E4727B and external instruments. In addition, you can see the actual software operation from this video. In this video, the discrete device is used with test fixture, and the DC and noise data viewing is demonstrated. At first, let's understand the hardware configuration of Keysight E4727B. The system consists of two types of hardware, that is E4727B hardware and the standard Keysight instruments. The E4727B hardware is PXIe interface module, main unit, and test fixture. The model number of this hardware starts from E4727B. Keysight standard instruments, embedded PC, and digitizer are mounted in PXIe chassis. Function generator and DC source monitor is the external instrument from PXI chassis. Very popular DC source monitor like B1500A is available. This is the actual photo of E4727B hardware, main unit, and test fixture. E4727B hardware PXIe interface module is mounted in PXIe chassis with embedded PC. Function generator and DC source monitor are external instruments. Next is the hardware connection. PXIe interface module in PXIe chassis is connected to the main unit. The cable is MDR cable, and all cable is standard accessory of E4727B. Digitizer in PXIe chassis is connected to the output of the main unit. The amplified DUT noise is acquired by the digitizer. DC source monitor is used for bias supply for both DC and noise measurement, and connected to the main unit by 3 Kelvin triaxial cables. The 3 cables are for gate, drain, and substrate. The DUT is in the test fixture, and the test fixture is connected to the main unit by 4 cables. 4 cables are for gate, drain, substrate, and source. The shorter cable is better for this connection. The shorter cable is important to avoid the environment noise and the smaller roll-off. This is the interlock connection between DC source monitor and the test fixture. The interlock synchronizes the read of test fixture. All instruments are connected by GPIB cables. The host PC is embedded PC in the PXI chassis. Function generator and DC source monitor is controlled by GPIB. GPIB cables are also included in E4727B standard accessory. Let's understand the DUT connection. Discrete device is measured by the test fixture. Test fixture has 28 pins IC socket, and you can use up to 28 pins package device. The test fixture has a flexibility of pin assignment. Pin assignment is decided by shunt connector. Any pin assignment is available. In this DUT, gate pin number is 1, source is 3, drain is 27. Many users of Keysight E4727B is using UEHA prober. Of course, E4727B can use probe station. The connection between DUT on UEHA and main unit is same with the test fixture. Let's go to the software operation. Before starting the measurement, you have to set up DC source monitor from hardware connections. The digitizer parameters are set from configuration window. The detailed parameters of digitizer is changed from digitizer setup tab. From noise measurement tab, you can set the averaging parameters. Other parameters like cable, LNA, and wait time also can change from GUI. The measurement condition, like a bias or frequency range, is set from measurement group window. Select routine and enter measurement condition in the table. Then start measurement. This measurement is an example of FET measurement. The DC measurement is executed at first. Before starting noise measurement, you can change the noise measurement parameters from noise setup window. You can change R source, R load, low pass filter, and LNA from the table. This video of fast bias is not edited to show the actual measurement time of noise measurement. The F noise and RT noise takes around 35 seconds in this example, but the time is depending on the measurement condition like averaging factor or start frequency and so on. Your measured data can check from Data Viewer. Push Display Plot button. Select bias you want to check. You can check DC data from DC tab and flicker noise from F-noise tab. The unit is changeable from GUI switch. Theoretical thermal noise line plot is available. The check of system noise floor is available by selecting single bias. From Post-Processing tab, you can change the yellow color trace. The yellow color trace is calculated data by using splice omit and smoothing functions. You can change the post-processing parameters from GUI. From RT Noise tab, you can check RTN. The B number can be changed, and the decimation is available. You can change the time step by decimation function. Also, this software can send the RTN data to B1538 software, and you can analyze the T-on, T-off. From Analysis tab, you can analyze the bias dependency of flicker noise. From Frequency Slider GUI, you can select the frequency of bias dependency by slicing one-point frequency. The spice parameter AF and KF is extracted automatically from the regression line. Of course, you can specify the frequency from GUI. From View Detail Info button, you can check the detailed information of device and measurement conditions. Thank you for watching.